looked like this. And the question was, they wanted to know if there was going to be enough information to show that the two triangles would wind up being congruent to one another. Well, as of right now, in order for those triangles to be congruent to each other, you have to have 6 things occur. You had to have all the angles have to match up and all the sides have to match up. When you're looking at this one, you have 2 sets of angles on both sides of the triangle. And we learned on Tuesday was that if these 2 guys are congruent to these 2 guys, what has to happen between those angles there? Yeah. Those also have to be congruent. We use that thing in terms of what we call the third angle theorem. So what happened was that these 2 had to be congruent to each other because as you start subtracting out values from the 180, those 2 angles at RKT and the UKT, those have to match up. Otherwise, bad things happen. But one thing you didn't learn about, which I completely had forgotten was in this problem, was this. So get your progression sheet out and let's talk about it. There's a little bit of information. Remember how we talked about things that we can infer from diagrams? One of the first things we said about inference from diagram, we put in there vertical angles, I believe. We said that if we saw vertical angles in a diagram, we can see right off the bat the vertical angles were congruent because there were sides create lines and so on and so on. We put a little asterisk that said, look for vertical angles. All right. Well, here's another look for. We're going to look for what's what's called shared side. Okay. We're going to look for what's called a shared side. I want you to put a little asterisk in one of the boxes with that, and we're going to find out what it does and what it looks like. For example, we have a triangle. Label it real basically A, B, C, and D. Do you guys agree by looking at that picture that the segment BD is shared between the 2 triangles, the triangle on the left and the triangle on the right? You okay with that? Okay. So there's this property in math. There's this property in math that says this. 2 equals 2. You agree with that? Okay. There's a property in math that says 12 inches is equal to 12 inches. But when we put measurement to something, we can also say that they're not just equal, they are congruent. Okay? So if I start throwing stuff around like that, what happens here is when it's a shared side, you can state that it is congruent, to itself because of what's called the reflexive property. The reflexive property basically states you're congruent to yourself. Okay. You look at your that reason bank. I believe it was the next bunch of things. It said numbers. 2 is equal to 2 segments. AB can be congruent to segment AB. Angles. Angle A is congruent to angle A. You are congruent to yourself. That's what the reflexive property states. Okay. So what happens then, in diagrams, just like when we did vertical angles, we were able to mark them and show that those 2 are congruent right away. We can do the same thing with segments if it's a shared segment. It's going to allow us to do proofs for triangles and stuff better later on. I completely overlooked the fact that they brought this in this section. I thought it was a later section, so when I was looking at the problems when we assigned that one, I forgot that this was there. So if you weren't sure on how to set up number 30, basically, only thing that you can do as of right now as far as to show that things are congruent is you could draw the picture, fill in the blanks with the tick marks, and then the example that we just did for 30, we could have said that these 2 are congruent, we would say by the third angles, and then this is congruent to itself because of reflexive. By doing that, you now have 3 sets of congruent sides, 3 sets of congruent angles. And again, the reason why this works You agree that this is a triangle-ish looking shape? Do you agree that this is the same triangle? Do you agree that those two triangles share that common side? Almost agree or disagree? Sure. All right, cool. So what happens is these triangles are congruent to each other because all their sides match. It just so happens that the one in the middle is shared. That's what we use when we talk about reflexive property. Right? Reflexive property allows us to do that. It'll also show up from time to time with angles, but we're nowhere near having to worry about doing that. We're nowhere near worrying about that. Not too bad. That's how you would have worked through with one like number 30. What else did you guys have? I know that was one question people have asked. Bless you. Is there anything else in those problems that you wanted to double check? Make sure you're all right. Which one? It's crazy what you said, number 20? Sure. Pull it up here. In number 20, it says list all the 4 pairs of congruent sides. And they say that so if you have to list out the 4 congruent sides, do you need to draw the picture? No. If you think about it, remember each of these letters represents a vertex in the polygon, okay, in whatever shape it is. So if I'm connecting my segments, PO, OL, LY, YP, that's just following the lettering around. Those are all segments. PO has to be congruent to which one's the other one? SI. OL has to be, it's OLID. It's almost solid, but it's OLID. Don't humor me. I got out of order here. DE. I was looking at the letters and I can't write. And then if I go YP, the other one has to be ES. Remember, YP is the same thing as PY. So if I wrote PY, what would my other one have to be? SE. So you have to follow the way the lettering is written. Okay. Okay. Any others in there? We're pretty straightforward. All right. Well, I want you to hold this because you got your quiz tomorrow, which we need to talk about. So get some extra paper out to write down because this is kind of important. This fun stuff that we have. It's OLID without the S. Quiz thingamajiggy, whatever tomorrow. We got 2.1, 2. So, what's that? Of all of this? Probably not for another couple of weeks. What's weird with what we're starting with right now is the way that I've always done the introductory stuff with the logic and the reasoning and things like that is that I like to meander little bits and pieces of certain sections to build up background knowledge of how you can get these things to work better starting next week. So in 2.1, I'm going to kind of go through all the different parts that were in each section of what parts I would worry about versus what I wouldn't. I'll use some examples. In 2.1, there was two parts to it. The first part of section 2.1 was more or less like the number pattern, 2, 4, 6, 8, what were the next three numbers in the sequence, that kind of stuff. Those things I don't really worry so much about. That's not really that big of a deal. Yes, ma'am. And then the other part of 2.1 was this. Counterexamples. Counterexample. What's a counterexample? What's that? What do you got? Perfect. A counterexample is any statement that negates what you're saying. And I like how you said it. Counterexample is any example or statement that disproves a hypothesis, if you will. All students take band. Take band. Or in band. What's your counterexample? There's your counterexample. All right. But see what I'm getting at here? It's any statement that can disprove a hypothesis. All books are rectangular. Sure, there are triangle books. Okay. Now, it would be pretty funny if you want to interject Joey into every single one of your counterexamples. That would be pretty funny. There's no reason why you can't. It's any statement that disproves a hypothesis. Let's see, where's jerks? I mean that nice. What was the one I had? All snakes are poisonous. Give me a counterexample. Gardner snake. Garter or Gardner? Gardner. Our oldest son, Connor, doesn't like snakes because Grandpa doesn't like snakes and Connor wants to be like Grandpa a lot. So we were up in Minocqua. You guys know where that is. It's 300 miles that way. Straight north. Way up there. Basically, you take Route 39 until it stops. It's what it is. It's right off 39. We were up there, I think it was last fall. Well, Columbus Day weekend last fall. We were outside in our relatives' backyard, and I think we're just starting a fire to make dinner and stuff. And we were just sitting there playing football, and all of a sudden our son looks down in the leaves and starts freaking out because there was a snake going by. So it was just a little garter snake, it was about this big or whatever. And he's like, he's freaking out. Then our youngest, at the time he was only 5, he goes, what? Picks it up. It's just a snake. And he starts walking around with it. My wife's just freaking out. He's just like, Moose isn't afraid of anything. So anyway, counterexamples. Same idea. You come up with anything to disprove it. 2.2. This is where all that P and Q stuff came from. So what we did here with the P and Q stuff, we started with them with what were called conditional statements. Okay? For example, excuse me. Guys. Neil and Joel. Conditional statements. Conditional statements were taking any generic statement and turning it into an if-then. Right? So we go back to the idea of correct, but I'm trying to think of a way to start from a statement to get into the if-then. All right, how about this? Turn this one into, here's generic. Whoa. Again, this is just a statement that I want you to turn into a conditional. The conditional is the P implies Q. This is where you go from a generic statement into something that is in what we call if-then form. Now, basically what that means is you're just adding the words if and then. Yes, sir? Perfect. You're not adding any words to it. Right? But again, if you are a motorcyclist, I'm just going to put motor C because I run out of space real quick here. If you are a motorcyclist, then you wear a helmet. That's a P implies Q. And you guys are already going through there saying true or false, and you guys are saying what? I don't know. That's not smart. How are you old enough to have a motorcycle license? Oh, okay. Yes, sir. Yes, sir. Grab the orange eraser. So when we did conditional statements, if you were writing them out, you would then say true or false. And if it was false, you would give us a counterexample. Is this true or false? It's false. Okay, it's false. All right. This is a false statement because not all motorcyclists wear helmets because it's not required in Illinois. Helmet laws, if I'm not mistaken, they are required in California. They are required in Florida, I want to say. They used to be required in Wisconsin, because I know that. I remember being younger. I've been riding motorcycles basically my entire life, and I've always worn a helmet. And I remember riding with people. We'd take rides up to Wisconsin. We'd go around Lake Geneva, or take a nice long ride up to. That's nice to go up there, but there's a lot of really nice back road stuff through Wisconsin to ride through. And there were times as soon as you crossed the Wisconsin border, people would stop and then put a helmet on and then continue on their way. Because even though that there aren't technically, well, when there were helmet laws, the only thing your helmet had to have on it was a DOT sticker, Department of Transportation. Those helmets were no thicker than this. It's not going to help you. That's not even, I mean, yeah, that's how that was. But yeah, Illinois, you don't have to wear one, just whatever. After we did conditional, you went to the converse. Remember what converse, or conditional, converse, inverse, contrapositive. Converse did what to this statement? Good. Q implies P. You flip it. If you wear a helmet, if you wear a helmet, then you're a motorcyclist. Is that true or false? What's the counter? Perfect. That's fine. Baseball helmet, football helmet, hockey helmet, bicycle helmet. Well, I'm using that as the same, so we'll do that. So, snowboarding helmet, skiing helmet, golfing helmet. I don't know if there is a golfing helmet. I guess if you have to wear a helmet when you're golfing, I'd find different people to golf with. Again, false. We can just say baseball helmet. If you were only wearing a helmet, your eyeball might not have hurt. Okay. Conditional, if then, converse, flip it. Inverse, what did we have to put in there? Not. Good. If you're not a motorcyclist, then you're not wearing a helmet. False. Exactly. If you are not, don't poke your eye. Again, false. Bless you. If you're not a motorcyclist and you do not wear a helmet, well, there are people that wear helmets that are motorcyclists. So you could be a baseball player that has a motorcycle, that wears a helmet, or anything along those lines. Yeah, it's true, but some motorcyclists wear helmets. You could say Murphy wears a helmet. Yeah. And then the last one was what we call the contrapositive. The contrapositive took the inverse and flipped it. Not Q, not P. If you don't wear a helmet, then you are not a motorcycle. Well, I guess if you don't wear a helmet, you're not a motorcycle. It's true because you're not a motorcycle because you're a human, but then you are not a motorcyclist. Need a marker. Oh, me? Oh, I only had my eraser. All right, so let's see here. I gotta write backwards. It's backwards. I can't read that. All right. And then lastly, this was a false one. Some motorcyclists don't wear helmets. It just never ceases to amaze me. There's nothing worse than going down the road, doing 60, and all of a sudden a June bug hits you. And I've had them hit me in the neck. They don't feel good at all. It's like the big giant, like a big beetle. Yeah. But when it hits you in a helmet, it does. And you hear this thunk, and like, I would not want that to hit me right here. Or I've had it hit my visor and it's splattered the blood. That's just gross. I just don't want that. Hey. Oh yeah. No, in like a 65, because I would never go over the speed limit. That would be breaking the rules. Yes. I didn't say at what point of accelerating or decelerating I was doing 60, but I was at 60. Or decelerating, I don't know. I don't remember. All right. Anyway, so that's what we did with the P and Q stuff. 2.4 then was the two weird things. It was the law of detachment, and then it was the syllogism stuff. So, whatever. Yeah. So with those two guys, just think about how the wording of those things went. When we dealt with what was called the law of detachment, the E just didn't show up. When he talked about what was called the law of detachment, we wrote out some statements, and then we would say, can you come up with a valid conclusion? And I think the example we did in here was, if Moose eats a pizza,
then he has Sprite.
Yep.
I remember this one.
Then he.
How do you remember this one out of all? Because Sprite right
So it started with like an if-then statement. Then the second sentence was along the lines of showing that the first part was true. So the if-then statement here goes, if Moose eats a pizza, then he has a Sprite. Moose ate a pizza. So the idea here was, is there a valid conclusion you can come up with on this one? Yes. In this case, we know Moose had Sprite. The difference between detachment and what we would call that the law of syllogism or the transitive property was that detachment was very choppy. If Moose eats a pizza, he has a Sprite. Moose ate a pizza, Moose had Sprite. So it sounds weird. Versus the other one, the syllogism or what we call transitive property. The law of syllogism, excuse me, was something like this. Tom is taller than Bill. So Tom is taller than Bill, Bill is taller than Frank, therefore Tom is taller than Frank. Now, one of the ways to be able to decipher if this occurs, notice how Bill is repeated. Bill is repeated. As Bill is repeated, it's the end of the first sentence, the beginning of the second. That's usually that is going to be the dead giveaway that you're using the law of syllogism versus detachment. Detachment, what's repeated is that first statement. If Moose eats pizza, then he has to write Moose ate a pizza. That first part's repeated versus this one, the second part's repeated. Okay? That's where that comes into play. That was the syllogism. After that, we went into 2.5 back here, and all we did in this section were algebra proofs. We didn't do anything else. We just did solve equations via the step-by-step scenarios. You guys were really good at it, okay? The only thing you have to worry about with algebra proof stuff is that you don't forget a step. For example, if I go 2 times the quantity x minus 1 plus 2 is 16, and that's my given. When you go through all of these, you have to make sure you've got your reason bank, because, oh, that's right, reason bank. So when I'm looking at one like this, what's the very first thing you're going to do? Yeah, we got our given in, yeah. If this was solved, if I gave you this problem and I wrote solve via 2-column proof, then you would write that down as your first step as the given. After you do your given, what would you do next? Yep. You show do your distributive properties. You have 2x minus 2 plus 2 is 16, and you called it your distro problem. Yeah, I would simplify here. Why would I simplify next, guys? Yeah, I can do minus 2 plus 2, and what do you get? 0. So I can rewrite it as 2x equals 16, because what you did was you simplified. Now what? Good. And then lastly, so this idea of doing a 2-column proof via the algebra is going to help us out tremendously starting up on Monday. Next Monday, Monday and Tuesday we'll be working on segment proofs using algebra. Wednesday and Thursday we'll work on angle proofs using algebra. A lot of angle addition, a lot of segment addition, subtraction, substitution, things like that. Maybe some midpoint stuff, maybe some angle bisector, things that we'll add to our progression sheet. But we always start basically with the algebra style, because then you get your feet wet with the idea of how the logic and the sequencing of it all goes. And usually you guys do fairly well on that one. I wouldn't be surprised if next Friday we do another little quiz on just segment angle proofs, just to kind of continue on with our stuff. Okay. And then the last chunk was that 4.1 was what we did on Tuesday. This 4.1 stuff was basically your congruency statements. Those congruency statements, the congruency statements that you guys were working with were ones where, label out what angles match what angles, what segments match what segments. Could you use a congruency statement, excuse me, to solve an algebraic problem? So if you had a diagram and you knew that like an angle A matched angle X, you could figure it out in the diagram and figure out which ones match with what. Stuff like that. It's nothing crazy. We aren't going to be like that number 30 we talked about a second ago, where you had to show all the stuff. We're not ready to do that yet. It's too. It was a good example to put in there, but it's a little too soon for us to assess on that. We'll come back to that after we do segments and angles. Okay, and that's kind of where we're at. It's a decent chunk. There's also what stuff all throughout this. We did things where what could you infer from a diagram? So if you have a diagram, could you tell if you have vertical angles? Could you tell if you have that reflexive side? Could you tell if something is perpendicular? Could you tell if something's been bisected? Is there given tick marks? Things like that. Can you say if things are true or false according to diagrams? Because we've been doing that for a while. But otherwise, what I was piecing things together of problems that I would definitely want to have you guys do this evening, I got 2 sets. On page 130, I want you guys to do numbers 12 through 19, and 27 through 30. And then on 274, 5 through 14. This 5 through 14 looks like a lot, but it's basically two pictures. It's a bunch of stuff off of two diagrams. Yeah, it's super quick. Okay. So take the time now, open the Chromebooks up, or take your phone, take a picture of the pages and the problems. I'll collect this tomorrow right before we take the quiz. I'm not going to give you guys homework over the weekend because that's just really, really mean. I'm only pseudo mean, not like crazy mean. Gonna go from there. But yeah, and then we'll start stuff fresh then Monday. Yes, sir. I do. I'll get you. Okay. Good for her. I just say don't do any math. Or math. You know, that'd be also a good thing. You know, you would change the lettering up a little bit. I would also maybe say that's probably a good idea. So go ahead, take pictures of it here, Chromebook it, screenshot it. We will collect this when we walk in tomorrow. We'll split everything up and go. Quite honestly, I don't think you'll need a calculator tomorrow. Even though we have the algebra proof stuff, you'll see that the algebra proof that we've done, guys, pretty easy. I mean, hopefully you can subtract 2 or add 4. I mean, I know you're worried right now. I can see in your eyes like, oh crap. I better wear sandals so I can use my toes. More than 10. Oh, yeah. Your hand is pretty bad. Okay. Where do you work at? Which one? Oh. No, that's cool. What my first job was I was a busboy and a dishwasher at Zubricki's Warsaw in McHenry. It was the Polish American Smorgasbord. It was a giant buffet. Yep. Hey. That's cool. That's very cool. You want your cake and eat it too. But no, yeah, I did that, and then I also had a paper route. I was a paper boy. I delivered newspapers on my bike. Yeah, it was something. It was pretty early. You get the newspapers to be dropped off at your front porch, and you have to bag them. And you have to take them out on your route. Back then, I think I had, I don't know, maybe 50 houses, 40, 50 houses, somewhere around there. So I mean, it wasn't terrible. It took 45 minutes or so. But I was 5th grade maybe. Yeah, sign up. For doing that, I don't remember. I don't think it was very much. But you basically got tips when you went to collect money for the subscriptions monthly. So if their bill was like $4, they'd give you 5. And you get to keep change, that kind of stuff. So, but no. But I think when I was a busboy, I might have been making it's probably $3-4 an hour, something like that. That was like I was 7th or 8th grade in that neighborhood. Yeah, and I saved all my money to buy a bike. Bought myself a Schwinn Predator. It's awesome. Yeah, that's cool. That's very cool. Yeah. No, and my kids, my wife and I differ on telling them to get jobs. I had a job all through. I had 2 jobs, 2 or 3 jobs in high school, and I was in sports and band. I was, yep, yep, yep. I was in everything. I was super busy. Oh yeah, oh yeah. It was just I was working during the season. I would work if we had practice after school. I would work like Friday nights or like a Thursday night, then I worked Saturday and Sunday. Unless I had a meet.
My secretary helped Friday, Saturday.
Yeah. It's depending on my schedule. But if I had night practice, I could do like an after school shift for like an hour or two. But that's when I was working at one store. But then when I was in, my other jobs were, I taught swimming lessons and I was a lifeguard. So depending on what place I was going to, I had different time schedules. I did. I was just far few in between, but I did. But I was busy. But I also had to pay for all my gas and all my insurance. So what's that? So yeah, I did all that and had time for my homework, and you know, you get busy. It's what you do.